All right, so today we're going to talk about rational exponents, which is 11-2. So basically what we're doing is, don't forget that rational just means fraction. So anytime that you see the word rational, that's just a fraction. So what we're doing is we're going to change exponents that are fractions into radicals. So things that are like square roots, cube roots, you'll see fourth roots and fifth roots and crazy stuff like that. But basically, don't let it scare you. All you're doing is getting rid of the fraction, which is good because I know we don't like fractions. So we're going to get rid of the fraction to make it into a radical. All right, so how we do that, it's a specific pattern that we follow. So say we've got something like 27 to the 2/3 power. So 2/3 is the fraction. That's your rational exponent. So in order to change it to a radical, the number that's in the denominator, or on the bottom, is the type of root that you're taking. So since this is a 3 in the denominator, that tells me that I'm going to take a cube root. So that's why I take the cube root of your base, so of 27, and then your numerator is what power you raise it to. So after I take the cube root of 27, then I'm going to square it. So always take your denominator, that's your root of your base, so we're taking the cube root of 27, and then we're going to square it. So it always follows that pattern. So when I take the cube root of 27, that's where I got this 3, and then 3 squared is 9. So we take this thing that's kind of complicated, this 27 to the 2/3 power, that's the same thing as 9. So that's why we do this, is so that we can take something that's ugly and complicated and make it much more simple. All right, so let's look at another example. So we have 4 to the 3/2 power. So the denominator tells me what type of root that I'm going to take. So I'm going to take the square root of 4, because that's my base. And then since the numerator is a 3, that tells me that I'm going to cube it. So once I take the square root of 4, that's 2, and then I still have to cube it, so 2 cubed is 8. Okay, so you're always following that pattern of denominators, the type of root that you're taking, and then you're going to square it. I'm sorry, cube it in that example. Okay, so let's look at a few more examples. So let's say that we just have something like x to the 11/8 power. That's a mouthful to say. So once I write this as a radical, I'm going to take the 8th root of x, and then I'm going to raise it to the 11th power. Okay, and we're not going to simplify that one because obviously that's something that we're not used to doing. So if you can't simplify it, you can just leave it like that. Okay, so it also works in the opposite direction. So let's say that we have something like the 5th root of 6 to the 4th power. So this is your denominator, and this is your numerator. So that means that we can take it from a radical into a rational exponent. So our base is going to stay the same. The 6 isn't changing. But now it's going to be raised to a power of 4/5. Again, whatever root you're taking as the denominator, whatever the exponent is your numerator. Okay, so let's look at another one like that. So let's say that we have the 4th root of x cubed. So when I change that into a rational exponent, we're going to have the same base of x, and that's going to be raised to the 3/4 power. Okay, so it follows that same pattern every single time. You take your rational exponent to a radical, or radical to rational exponent. Okay, So now we're going to combine various rational exponents in order to simplify. So we are going to simplify rational exponents. And when we do this, we're going to have to review your exponent rules at the same time, because I know it's been a while since we've done that, but we did it with polynomials a lot. You just didn't realize that you were doing it. So it'll make more sense once I actually apply to an example. So let's say that we've got something like 25 to the 3/5 power times 25 to the 7/5 power. All right, so before you change both of these into radicals, you want to get this into one thing by itself, because right now we have two terms and we want to get it into one. So since we are multiplying these two things together, really all that we're focused on right now is the exponents. Your bases aren't going to change. So when I multiply 25 to the 3/5 power, hang on, I wrote that incorrectly. This should be 25. The bases should be the same. So since those are both 25s, that's going to stay as 25, so that's not changing. Your base doesn't change. Now when I multiply 3/5 times 7/5, if you remember your rules of exponents, when you multiply exponents, you're really just adding them. So when I multiply 3/5 times 7/5, that really gets me to 10/5. So I'm only adding the numerators, or the numbers on top. Okay, so when you're multiplying rational exponents, you're really just adding the exponents. So we know that 10/5 reduces to 2. So now we have 25 squared, which simplifies to be 625. So that's the reason that you want to combine everything first, is because you don't want to have to take the 5th root of 25 cubed and the 5th root of 25 to the 7th power to get to this, to then to get to that, and then to that. That's a whole bunch of craziness. So whatever you have in the beginning, combine that first and then start to simplify. So always take your two terms, combine them into one before you start simplifying. Okay, so let's look at another example. It'll be a little bit different. So we're going to have 8 to the 1/3 power divided by 8 to the 2/3 power. So when we multiplied, we added the exponents, but now that we're dividing, we're going to subtract the exponents. Okay, so multiply and add go together, division and subtraction go together. So when I have 8 to the 1/3 power divided by 8 to the 2/3 power, remember our base of 8 isn't going to change, but if we have 1/3 minus 2/3, that's going to be negative 1/3. And now, this is where we can change it into a radical. The reason that I didn't change this into a radical is because I could simplify this exponent. But this one I can't simplify. So now, I'm going to take the cube root of 8, and then we're going to raise that to the negative 1 power. So the cube root of 8 is 2, and then 2 to the negative 1 power, we don't really have negative powers, so you just make it back into a fraction. This problem is not the nicest. I don't believe there's one like this on your assignment with a negative exponent. I wish these were flip-flopped so that we didn't end up with a negative exponent. But anytime that you have a negative exponent, basically what that means is you just put it into a fraction at the end. So I apologize that that was like an extra step that we didn't like, but hopefully that won't appear in your assignment.